My name's Denise, and I work at Pixar on the UST team, introducing my proposal for allowing alternate implementations of Libwork. For this meeting, I'll be going over why we're doing this and a bit of background about it, the solution we're proposing, as well as the methodology for how we came about proving that our solution works, and then some findings and callouts for how a user will interact with this and things they should be aware of when creating their own alternate implementation. So the goal of my proposal is to allow users to provide their own backends and remove reliance on TBB's task management system. And just to provide some quick background, Work is our library for dispatching tasks in parallel, as well as providing other parallel algorithms like parallel reduce and sorts and whatnot. And the reason why we're making this change is because some of our users would like to use their own task management systems, and they found that when using it with OpenUSD, and especially TBB's task management systems, their schedulers don't play as nicely with TBB's scheduler. And so it'd be nice if we could just kind of remove that reliance on TBB's task management system specifically. We'll still be building with TBB because we do rely on their concurrent containers. The solution we came up with is creating this work abstraction where we'll, instead of calling TBB directly in our code, we'll call this function prefix with work impl to indicate that it's a point of customization. And in a different file, which I'll get more into later about the structure, we'll actually define that function and use whatever work library we need. And so now you might be thinking, since this feels like something a plugin can do, why not just use like virtual functions or something like that? And the main reason for that is that because we generate tons and tons of tasks in our code base, we wouldn't want to add the overhead cost of having to do a vtable lookup with every task that's generated. And so that's how we kind of came about this solution. The way we came up with this abstract API and prove that it is generalizable enough is we decided to implement Work with two other task management libraries, which I'll get more into how I chose in the next slide. But we ended up deciding upon Grand Central Dispatch and TaskFlow. And we'll provide these as examples under PXR extras. And in the future, we'll continue to build these examples, but not necessarily support testing them, since we don't want to maintain these examples. I guess to preface though, we have tested them internally. And so the reason for this is, or why we're making these two implementations, is that we want to discover what implicit work constructs we are currently relying on and supporting, as well as creating an API that's general enough for at least other task management libraries besides TBB, with the caveat that this is not a API that we are trying to like make work for every single library out there. And now, as I said, I like pictures. So I made a little matrix of what factors we're looking for and how the task management libraries we looked at fit into these categories. I won't go over all of these. I'll kind of go over the factors and then explain why we chose TaskFlow and Dispatch. The biggest factor was mostly if a specific user requested this or if it was a very popular open source Hello system that is commonly used. Dispatch was kind of a no-brainer in terms of it was specifically requested for, and then we took a look at OpenMP as well as TaskFlow, and both seem to be fairly prototypable, meaning that it's easy to build against and get off the ground going. And it also had a fair number of API calls that kind of aligned with the current APIs, TBB API that we were using. And then compatibility is more so of after we made the implementation, how well these task management libraries actually like worked within our code. We actually started implementing with OpenMP, but then quickly realized that it wasn't the most task-based system, and so we discussed having a bunch of infrastructure to make it work for our system and decided that this might not be the direction we want to go and ended up settling for TaskFlow. Our findings from creating and building with two different work libraries is we decided we want to treat this alternate work backend as a third-party library, meaning that we can't have any dependencies on USD to avoid cyclic dependencies in terms of what exactly we require of this library. What we'll be looking for in USD is a file called impl.h, which you can structure it however you want. If you want to put all your functionality in there, you can, or you can split it up into other header files, CPP files. We just require that there is at least an impl.h, as well as some sort of config file to tell us what other dependencies you need and how to hold those in. As I mentioned earlier, this library can be header only. The freedom is given to the user. And then in terms of the current structure, since we will also be abstracting TBB out of Work, all the TBB implementation will now live under Work TBB that will still exist under Work and be built into Work, but we'll have some CMake configurations to basically toggle between building with an alternate library or building with this Work TBB library. In terms of some other findings that we discovered through the nuances between these different systems, we noticed that scope parallelism, which is a mechanism that prevents the calling thread from stealing tasks outside the indicated scope in order to prevent prevent deadlocks when we wait. TBB does this with a task arena class that provides this work isolation, whereas dispatch is more straightforward in that calling wait just simply blocks, and so that we don't need to worry about task stealing in the calling thread. However, with task flow, this is a little bit more tricky since we realized when implementing the task flow, scope parallelism itself cannot spawn a thread to handle the work within the scope, which might seem straightforward or more like logical at first, but in TaskFlow's API, we noticed that there is a API to do some sort of scope parallelism, but it does so by spawning another thread to handle that, which broke this work construct that we relied on. And so we had to work around that by creating this thread local executor stack. Continuing on with more variances that we noticed between these different systems, and this slide specifically focuses more so on the differences between other libraries and TBB's API that allows us to kind of have more control over the memory allocation and scheduling tasks. In particular, especially with the oncoming OpenExec work, we need some sort of API, which we're going to call defer for now, to allocate memory for a task without running it, since that's not something we currently support in work. And so taking a look at dispatch and task flow, there didn't seem to be a great way of allowing the user to take control of this memory. And so we decided to say, we'll provide the API. If you can implement this feature, go for it. But if not, then at minimum, just return the handle to the callable, and we can run that later when needed. And so the reason why we're doing this is because we still internally will use TBB. And so we'll want to continue supporting that and the optimizations that we take advantage of in our current system. Similarly, for thread limits, TBB allows us to limit the global number of threads used in the system. And so also looking at dispatch and task flow, we realized there wasn't a great way of enforcing this limit, as dispatch relies on the OS to schedule and limit threads, and task flow only grants us some sort of limit per executor. We decided we'll require the bare minimum that your implementation will either support maximum physical concurrency or at the very least a serial implementation. And we've also added tests and documented that as well. If you don't implement these functions and provide like the bare minimum, we haven't fully tested this yet, but it is likely that we'll see performance regressions, especially with the OpenExec code that takes advantage of these optimizations. We'll make sure to document that as well, either in the code or in documentation. But that is something that if you want to make your own work backend, you should be aware of when choosing your system. That's all I've got. Does anyone have any questions?